In this video, you're going to be learning about data structures. Data structures are special constructs that we use to make working with common information easier in our programs. Python has many built-in data structures, and we're going to be talking about 3 of them in this video. Once again, data structures are all important when it comes to working with data. They're specialized formats that allow us to organize and store data efficiently in our programs. You can think of them as data with structure added. Python has built-in structures, or you can create your own. The first structure I'm going to teach you is called the list. Lists are exactly what they sound like. They are ordered collections of items, very much like the to-do list that you might make for yourself. By ordered, it means that the order in which they occur in the list is important and is preserved. There are multiple ways to work with lists in Python, and you can create them using a bracket syntax or a special list constructor. To create a list, you use brackets, and inside the brackets, you put a comma delimited list of values. Those values can be of any data type. To access individual values, you use the index of the list item, starting with 0. You can add items to list using append, and you can remove them using either the remove method or the special delete statement in Python. Let's look at an example. Okay, we're going to write a really quick program that's going to demonstrate how to create and work with lists in Python. I have my interactive console, my shell on the left, and I have a blank editor in idle on the right. First thing I'm going to do is I'm going to save this to my flash drive so I can refer to it in the future. I'm going to put it in my Python projects directory, and I'm going to call it list.py. Okay, now that the programs are getting a little bit more complicated, we're going to start adding comments. Comments begin with what looks like a pound sign, okay, what looks like a hashtag. So the first thing I'm going to do is I'm going to create a list using the bracket syntax. So I'm going to create myself a little comment. It says create a list using the bracket syntax. I'm creating myself a list called presidents, and using the assignment operator, I'm creating a 3-item list. Washington, Adams, and Jefferson. Remember, with the list, order is important. So Washington is first, then Adams, then Jefferson. So the order of the presidents is obviously important. See how I have my brackets and then a comma delimited list, in this case of strings, but it could have been any data type I wanted. So now I have my list, there's 3 items in it, but I want to know how to access an item in the list. Create myself another comment, access using index, and then I'm going to print out to the screen the first item in the list. Okay, what does it mean to be 0 indexed? What it means to be 0 indexed is that when we start with our list, we start with 0, and then 1, and then 2. Sometimes when you're numbering things, you say 1, 2, 3, 4, 5. But a lot of times in computers, our items are 0 indexed, which means they start with 0. So if I want to print out to the screen the first president in the list, I say presidents, open bracket, 0, close bracket. That's how I ask for the first item in the list. All right, let's see if this works. I'm going to Control S. That's going to save my file, and then I'm going to F5. That's going to run it in my shell. As you can see, it output to the screen, first item in list. And the first item, represented by index 0, is Washington. Okay, let's go a little bit further. We've got a couple other things we can deal with. What if I want to print out the first 3 items in the list? Well, here's the syntax. Notice how it says presidents, open bracket, 0:3, end bracket. So I can access an item using its index, or I can use a range of indices. To bring back multiple items from the list, you use this special range syntax. In this case, mine says presidents bracket 0:3 bracket. What this means is that I'm going to be asking for the first 3 presidents. I'm going to be asking for index 0, 1, 2, and then when it gets to 3, it knows to stop. This syntax can be very confusing for people. You just need to know that the 3 will not be included. It will, in this case, include everything up to and not including 3. In other words, index 0, 1, and 2. Another thing you'll notice here is that I had to cast these multiple items that come back from this special range syntax to a string before it could be added to this prefix. So when I run this, it will print out the first 3 items of the list. Let's go ahead and do that. Control S to save, F5 to run. Notice how it brought back the list even with the brackets. That's why we had to cast it to a string. We weren't asking for an individual value. We were asking for a big chunk of the list. Okay, what if I wanted to print out everything in a list? Well, I could use a standard for loop, and I could ask it to go through my list. Let's do that. First, let's add a comment. It says that we're accessing everything using a loop. Let's print out to the screen that we're going to go through the items one by one. Then we're going to write a very quick for loop that prints out each value. My presidents list is just like any other sequence. I can go through it using a for loop. In this case, I'm using P as my iteration variable, and then the only command that's going to run for every iteration through the loop, for every item in the list, is it's going to print the list item to the screen. Let's go ahead and save our project, and we'll run that to see what it looks like. Control S, F5. So every time I do this, I'm running the whole program, which is fine. You'll notice that now I've added loop through list items one by one. Notice how it listed in order the presidents: Washington, Adams, Jefferson. It's important to remember that a list does retain its order. It's an ordered collection. Okay, what if I wanted to add to the list? How could I do that? To add to our lists, we use the append method. Go ahead and add a comment and then print out to the screen that we're going to add Madison to our list of presidents. To add to a list, use the append method and then provide the value you want to add. Let's go ahead and print out to the screen our entire list of presidents, casting to a string first to verify our work. I'm going to go ahead and Control S my program to save it, and then I'm going to run it. This time I should see that I added Madison to the list. F5 to run. Notice how there's my message to the screen, add Madison list item. Now I have a 4-item list. Notice how Madison was added to the end. So now I have Washington, Adams, Jefferson, and Madison. Using the append method, we can update our lists. Last but not least, how do I get rid of a list item? How do I remove it? Let's do that one now. I'm going to add a comment, print out to the screen that I'm going to remove Madison. And now, using the remove method, I can remove any item I want from the list. Now let's print out what is left. Make sure you cast the president's list to a string so you're able to print it out to the screen. Control S to save, F5 to run. As you can see, now I've added an additional comment. Something else to the screen that says remove Madison list item. And then I used the remove method, which removed Madison from my list, leaving me with just Washington, Adams, and Jefferson. The next data structure we're going to talk about is called the tuple. A tuple is just like a list. It's an ordered collection of items. A tuple, however, is immutable, which means it can't be changed. You can't add, edit, or remove any of the items in it. There's also a slightly different syntax for creating a tuple than there is a list. Creating a tuple is simple. All you have to do is list values separated by commas. You can optionally enclose these values in parentheses. As I discussed previously, a tuple is immutable. It cannot be changed. Therefore, you cannot add, edit, or delete any of the individual values within the tuple. You can, however, remove the entire tuple using the del statement, which is short for delete. Okay, now we're going to write a quick demo program to show you what a tuple is. Once again, I have my shell or interactive console on the left, and I have a blank program file on the right. And before I do anything else, I'm going to save this into my Python projects directory. And I'm going to call this tuple.py. As we discussed earlier, a tuple is just like a list, except for it can't be changed. It is immutable. To show you just how similar these things are, I'm going to show you how I can start with the exact same program as before for list and just make very small changes because they're that similar. So I copied and pasted the program that I wrote for the list data structure, and now I'm going to make some small changes to it. So in this case, I'm creating a tuple, not a list. And a tuple does not use bracket syntax. It uses comma-separated values with optional parentheses. I'm going to go ahead and replace the brackets with parentheses. Well, remember, for a tuple, if I wanted to, I could just have that. Okay. Then I'm going to make some small changes throughout the program to indicate that I am not working with a list, but a tuple. Anywhere where it says list, I'm changing to tuple. And then down below, where I add and remove, making small changes. So I know that some of this code is going to fail, but I want to prove to you that a tuple is immutable. And the best way for me to show you that is to show you what you cannot do with a tuple. So it's just like a list, but you can't change it. So we are going to go ahead and save this, and we'll see how much of the stuff I was able to do with a list I'm able to do with the tuple. I Control S to save. You can also do File Save, and then you can run using Run Module or F5. I'm going to go ahead and F5 and see what I can do. So just as before, I'm able to create the tuple with 3 items in it. I'm able to access the first item using the 0 index. I'm able to bring back the first 3. I'm able to loop through it. But then when I get to adding the tuple item, not list item, it fails. It says tuple object has no attribute append. And this is another way of telling you that you just cannot append to a tuple. So what you're going to have to do is go in here and delete these 4 lines, the ones that have to do with adding to the tuple, because you cannot add to a tuple. It's immutable, it cannot be changed. Let's go ahead and save our program and let's run it again. F5. This time you see that it's complaining about there being no remove attribute. Well, this is also because there is no way to remove an individual item from a tuple because a tuple cannot be changed. It's immutable. Once again, you cannot remove from a tuple. So we can leave the first 4 major blocks in here because those are all the same as with a list. You just can't change it. So as you can see, everything else is the same except for the syntax for creating the tuple itself. What you can do if you want is you can remove the entire tuple. You cannot add individual items, you cannot update individual items, you cannot remove individual items, but if you want, you can remove the whole thing. So I'm going to show you how to do that. You can remove the entire tuple using the del or delete statement. I'm going to print out to the screen that I'm removing the entire tuple. Then I'm going to use the del command to delete the president's tuple. Afterwards, I'm going to print presidents. And the reason why I'm doing that is to prove to you that it's been removed. If you try to print something that's been removed, you should get an error. Let's go ahead, Control S, and we're going to run it all again. F5. This time, you can see it says removing entire tuple. And I know it removed the entire tuple because when I tried to print presidents, it said it is not defined. It's not defined because I removed it. I deleted it. I destroyed it. So that is what a tuple is. It's an ordered collection, very similar to a list, that simply cannot be changed. And the fancy word we use for that is we call it immutable. The last data structure we're going to talk about is a dictionary. A dictionary is much different than a list or a tuple. It is an unordered collection of what we call key value pairs. So there is a unique identifier called the key that points to the value associated with that key. This is often referred to as an associative array in other languages. You can think of a dictionary as a real dictionary. Think about how you would look up a word. The word is the key, which points to the value, which is the definition listed by the word. You can create a dictionary a couple of different ways. We're going to use the curly brace syntax. So to create a dictionary, you use the curly brace syntax. Inside the curly brace, you list key value pairs separated by commas. To access an item in the dictionary, you use the dictionary's name and then the key that you want to look up, not some index like we did before. You can add or edit the dictionary using the update method, and you can remove using the del keyword. Now we're going to demonstrate how to create and work with dictionaries. Just as before, I have my console on the left, I have a blank program file on the right. The first thing I want to do is save this to where I keep my Python programs. And I'm going to call it dict, as in dictionary, dict.py. All right, the first thing we want to know how to do is how to create a dictionary, because it's different than the other data structures we've worked with. I'm going to create a comment. Remember, these programs are starting to get more complicated, so we want to make sure we add comments. I'm going to create a dictionary called states. And here is my syntax. For a dictionary, you use the curly brace syntax. What you'll notice is I have two key and value pairs. In this case, CO is my key, which is the short state code for Colorado, and my value is Colorado. I've got another key, WA, which points to the value Washington. So this is a perfect example of what you might use a dictionary for key value combinations. If I want the full name of the state that corresponds with CO, I would ask for the CO key value. So CO is the key, Colorado is the value, WA is the key, Washington is the value. To look up the value, you use the key. So how do I look up a value of any of the key value pairs? Well, if I want to look up the value for a key, I use a syntax like this. I can access it using the states dictionary asking for the Colorado key. So as you can see here, I use this bracket syntax. This is the name of the dictionary, and then I have a bracket, and then this is the key that I want the value for. So this is how you would get the value for a single key. Remember, in a dictionary, all of the keys have to be unique. It's very similar to the actual dictionary you might use to look up words. We don't have non-unique words. Every word is unique and points to its own definition. Okay, so what we're going to do is we're going to save this, Control S, and then F5 to run. If I do this, I should get back the value Colorado when I ask for the value of the CO key. So this is exactly how you create a dictionary, and this is how you would access a single value. To access multiple values or to go through the whole thing, we can use a loop. It's no different than any other sequence. We should be able to loop through it. Now, what does make a dictionary different is that it's unordered. So what we're going to do, we're going to build ourselves a little for loop, and we are going to go through the dictionary. We're going to have to talk about this though, because this is a little bit more advanced. Adding a comment, letting everybody know that I'm going to loop through the dictionary. And I use a special for loop that we'll talk about to go through all the items in the states dictionary. For each one, I'm going to print the key and value. Let's go ahead and run this, and we'll talk about it. Control S, F5. Notice how I printed out to the screen, loop through dictionary one by one. And then you can see I have the key value pairs, starting with Colorado, ending in Washington. So what you'll notice here is that instead of having 4x or 4p, having a single iteration variable, we have two. And then we're not looping through states necessarily. We're looping for what comes back when we ask for the items inside states. So we need to use this items method to bring back the items from the dictionary that we want to loop through. So in this case, every time we iterate through the loop, we're getting the key and the value. We're getting two pieces of information assigned to variables that we can use. So this is how you would loop through a dictionary. Okay. Now we're going to practice adding to a dictionary using the update method. So I'm going to add a new item to our dictionary. It's going to be for my home state of Indiana. The key is going to be uppercase IN and the value is going to be Indiana. We are going to use the update method in order to perform this. Let's see what that looks like. I'm going to create myself a comment about the new key value pair I'm about to add, and then I'm going to let everybody know that I'm going to add Indiana to the dictionary. To add it to the dictionary, I use states.update, and then I provide my key value pair. Now I want to make sure that I did it correctly, so I'm going to print out the entire dictionary to the screen, and to do that I need to make sure I cast it to a string. So by using the update method and by providing the key and value I want to add, I can effectively update our dictionary. Let's go ahead and take a look at that. Control S to save and F5. As you can see, there's a new message. It says add Indiana to the dictionary. And now when I print out my entire states dictionary, you will see that there are 3 key value pairs. The latest one I added has a key of IN that points to the value Indiana. Last but not least, I'm going to show you how to remove a key value pair from a dictionary. To remove a key value pair from a dictionary, you need to use the del statement. Just like I've mentioned before, with all these data structures, there may be more than one way to do something, but I'm going to show you how to do it one way, and as you expand your programming horizons, you'll realize that there's always another way to do the same thing. So let's go ahead and we're going to remove Indiana from our dictionary. What does that look like? Let's go ahead and create ourselves a comment about removing the key value pair. Let's print out to the screen that we're about to remove Indiana from the dictionary. And then to remove it, we're going to use the del statement. And we need to say which one of the keys we want to remove. So what I have here is I'm going to use the del statement, and then I'm going to specify which one of the keys I want to delete from the dictionary. In this case, I'm deleting the IN key, which points to the value Indiana. And then at the very end, I'm going to print out the entire dictionary, first casting it to a string to make sure that I removed it the correct way. So let's go ahead and Control S to save, and we are going to F5 to run. This time you'll see that I have appended a message that says remove Indiana from dictionary, and when I print out the contents of the entire dictionary, you only see that there are 2 key value pairs. So this is how you would remove from a dictionary.